Page 38, we're finding the equation of a trig graph. First of all, we need to identify whether it's a sine or a cos graph by where it starts. And for this, by starting, we mean at the y-intercept here on the y-axis, and looking and seeing where the curve goes from there. Because if you recall, a sine curve starts at 0 and goes up. A cosine curve, cos of 0, is 1, so it starts at the top and goes down. So we really need to remember those. If you forget, of course, you can find sine 0 on the calculator and you'll get 0, and cos of 0 is 1. So looking here, we can see that our curve starts here. Here's the y-intercept and it comes up. So clearly this is from a sine curve, or a sine curve would be a good curve to model this data by. Our y-intercept is at the top and we're coming down, so this would be a cosine model. This one here, we're starting at the y-intercept and moving down, but not with a curve like the cosine one. So actually this one here is like our sine curve. If I draw a sine curve in red, you can see that it's like the sine curve, but it's a reflection of it, and that would make this a negative sine curve because it's actually a reflection of a sine curve. And similarly with this one, you can see it's a reflection of the cosine curve that normally starts here and goes down. This one, our y-intercept is here and we're moving up, so it's actually a reverse, a negative cosine curve. Right, there are 4 different places where values can be put into the equation, but we only consider 3 of these. So just reminding ourselves, A here changes the amplitude, that's the height of the wave. Our plus D translates the curve up and down. And B here, inside the brackets next to the variable, affects the period, changes the period. So looking at our graph here, we start with y equals, of course. I can see that it's starting, here's the y-intercept, and coming down, so it's clearly a cos graph. The maximum here is 4, the minimum value is -2, and halfway between those, you can work it out, or we could put in some values to help ourselves. We could use our fingers. 1, 2, 3. 1, 2, 3. I can clearly see that the value of 1 here is going to be halfway between -2 and 4. So there's actually implied an axis in here. Our cosine curve has been translated up 1 unit. Now in front of the cosine we need the amplitude of the wave, the height of the wave. I can see that it's +3 and take away 3. So the amplitude is 3. And then that leaves me with the variable in here, and of course B, which comes from the period. Now the normal period for a cosine curve is 2 pi, which is what it's here. So this is just 1x, or just x, because the period is the normal period for a cosine curve. There is a formula over here which we'll use soon to help us work out b, the number in front of the variable. I like to write nu down here. B equals 2 pi divided by the nu period. And we'll see how to use that in a minute. So moving down to look at 2 examples here. So if we start with this one, y equals, always start with y equals, identify the y-intercept, and then it's moving up, so clearly this is from a sine curve. The maximum is 4, the minimum is -2, just as in the example above. Halfway between 4 and -2 I can see is clearly 1, So there's implied an axis in here. Curve has been moved up one. The amplitude, once again, 1 plus 3 is 4, 1 take away 3, so the amplitude is 3. Now we need to think about the period. So, and the number in front of the variable, we call it b in our formula. So we'll write a b there for now. And the formula is that b equals 2 pi divided by the new period, or the period that I can see here for my graph. So finding where one cycle fits. One cycle starts here, finishes here, and then another cycle begins. So the new period is clearly 4. Doing some simplifying, 2's into that go 1, 2's into that go twice, is the same as pi over 2. So coming back to my formula now, and erasing the b, we can see that the number in front needs to be pi over 2, and that will ensure that I get a period of 4. Okay, number 2, maximum is 40, minimum value is 20, halfway is 30, and we'll put in our little implied axis. Clearly we need a plus 30 on the end. The whole graph is being translated up, so the axis that was at 0 is now at 30. I can see the amplitude of the wave clearly is 10. We need to decide whether it's a cosine or a sine. We're starting down here and curving up, which is the opposite of our cosine curve that normally starts at the top and curves down like that. So it's clearly a reflection. It's a negative cosine curve. We need a variable, and we'll put b in that place at the moment. Now to work out b equals 2 pi divided by the new period of this graph. So we're looking for one complete cycle, and there it is there. One complete cycle before it starts again. It's a bit hard to read off this graph. I think we'll assume, let's go for 12. We'll assume that it's completed one cycle in 12. It just makes the maths a bit easier. And simplifying this is the same as pi over 6. 2's into that go once, 2's into that go 6. So now I have a value for b. We'll erase that and we'll put in pi over 6. Now perhaps you might need to watch the video again. Just make some markings on your own page and try those questions.